Myself T. Ramreddy. I'm from Electronics and Communication branch. Today topic is about FPGA based orthogonal PAM op-amp implementation for 100 GBs Ethernet SerDes. Introduction. With it, the rapid growth of the high-speed data communication and the cloud computing, there is an increasing demanding for the ultra-fast and energy-efficient serial data. Transmission systems. Modern Ethernet standards such as 100 gigabit and 100 gigabit Ethernet, 100 GB rely on advanced serializer deserializer SerDes architecture to achieve extremely high data rates over copper optical channels while maintaining signal integrity and low power consumption. To efficiently utilize the available bandwidth and minimize transmission errors, multi-level modulation techniques are employed for SerDes architectures among the orthogonal pulse modulation. OPAM is a orthogonal pulse amplitude modulation, has emerged as a promising approach due to its ability to increase the data throughput while reducing the interference ISI and improving noise tolerance. OPAM combines the benefits of orthogonal signaling and amplitude modulation, enabling the symbols to be transmitted simultaneously with reduced crosstalk and enhanced spectral efficiency. In this project, the FPGA field programmable gate array platform is used to implement and verify the orthogonal PAM op-amp technique for a 100 GBs Ethernet SerDes system. FPGAs provides an identical testbed for high-speed digital signal processing because for the parallel architecture reconfigurability and the hardware level performance, allowing rapid prototyping and validation of communication algorithms. The study focuses on the design, simulation, and the hardware implements of the op-amp encoder and the decoder blocks, synchronization mechanism, and equalization schemes required to achieve reliable high-speed data transmission. The implementation aims to demonstrate the op-amp modulation can achieve higher spectral efficiency, lower bit error rate (BER), and the better channel utilization compared to traditional PAM schemes used to current SerDes designs. The project overview. The FPGA based orthogonal pulse amplitude modulation op-amp implementation for 100 GBs Ethernet SerDes project focuses on the design, development, and the verification of an advanced modulation scheme optimized for ultra speed serial communication. The project aims to demonstrate how orthogonal op-amp can be effectively implemented using FPGA hardware to enhance data throughput, improve the spectral efficiency, and the reduced bit error rates in 100 gigabit Ethernet serializer or deserializer SerDes systems. In the conventional high-speed serial interference, the modulation techniques such as PAM or PAM for four-level pulse modulation and widely used. PAM increases bandwidth efficiency compared to traditional enhanced signaling. It suffers for limited noise margin, increased linearity requirements, and the higher signal distortion technique introduces orthogonal components, allow simultaneously data capacity and robustness and channel impairments. This project leverages the flexibility and the processing power of field programmable gate array. Implement and evaluate the op-amp modulation and the demodulation blocks. The FPGA serves as a reconfigurable hardware platform for measurement. The implementation includes modules for op-amp, encoding, decoding clock, and the data recovery CDR, error detection, and the equalization, all designed to meet the strainer timing and the synchronization requirements of 100 GB's communication standard. Objectives. The primary objectives of this project to design the implementation orthogonal pulse amplitude modulation system of the FPGA platform for high-speed data communication in 100 GB's Ethernet SADAS application. The project aims to explore how op-amp can enhance transmission performed by performance by improving spectral efficiency and reducing bit error rates compared to traditional modulation schemes. Specific objectives are the to study and understand the principles of orthogonal op-amp, analyze the theoretical background modulation techniques and the orthogonally concepts used in the op-amp for high-speed digital communication, to design high-speed op-amp receivers architecture, develop the block level design transmitter and the receivers suitable for 100 GB Ethernet SATA systems, to implement op-amp modulation and the demodulation on FPGA, utilize the hardware description languages such as VHDL Verilog to realize real-time modulation, demodulation and the synchronization process. Mm, Synchronization process to integrate key SADAS components with the op-amp systems, implement clock and the data recovery, serializer, deserializer functions and the equalization techniques for a signal integrity improvement, to analyze the system performance of the reliability, evaluate bit error rate BER, signal to noise ratio, eye diagram equality and the overall power efficiency and various channel conditions, to compare op-amp with conventional modulation schemes, benchmark op-amp's performance against NRZ and the PAM 4 in terms of the data rate, signal quality and the implementation complexity, to demonstrate feasibility for next generation Ethernet standards, prove the FPGA based on the op-amp can serve as a practical and efficiency modulation solution for a future high-speed communication interface. Prerequisites and the prerequisites and the requirements before starting the FPGA based orthogonal PAM op-amp implementation for the 100 GB Ethernet SATA project, solid understanding of the following technical areas and the tools is required. This prerequisite answers the concept of the high-speed communication modulation and the hardware implementation can be effectively understood and applied. Digital communication fundamental based on the digital communication fundamental, signal processing and the modulation theory, concepts of the orthogonal pulse shaping and the filter design. And the fourth one, high speed serial communication SADAS concepts. Fifth one, MATLAB simultaneous or eventual simulation tools. And the requirements are the hardware requirements and the software requirements. And in the hardware requirements, they are the TMS coil and the pulse generating circuit, microcontroller controller unit, measurement instructions. Software requirements are the microcontroller processing environment, control software and some of the other software requirements are used, technically used in the we know that the technical events and the transitional magnetic simulation and some of the other FPGA components. In the circuit diagram we see the SADAS in temperature chamber and it is about 60 GBs. Detailed design and the implementation. And the detailed design and implementation are the three types of microcontroller control system and the pulse generating circuit, TMS coil, and these are the FPGA components and programmable controller. Testing and the validation is nothing but the testing and the validation of the assembling the voltage regulator circuit. It must be rigorously tested to ensure the at last the conclusion of this project is, yes, we will written conclusion section for your project report on FPGA based on the orthogonal PAM is nothing but orthogonal pulse amplitude modulation implementation for the 100 GB Ethernet SADAS technically and suitable for academic submission. The FPGA based on the orthogonal PAM or PAMP implementation for 100 GBs. Ethernet does provide demonstrate the potential of the advanced modulation schemes in achieving the high speed and the energy efficient data communication. Modulation op-amp enables the improved spectral efficiency, enhanced noise tolerance, and the reduced inter-symbol interference compared to the conventional PAM4 and NRZ schemes. Implementing op-amp on the FPGA platform allowed for practical validation of its performance in the real-time hardware. Highlighting the advantages of the reconfigurably parallel processing and the low latency operation offered by architecture proved effective in maintaining signal integrity and achieving reliable transmission at 100 GBs, which is essential for next generation Ethernet and optical communication networks. Through design simulation and the performance evaluation, the project successfully established the orthogonal path can serve as a promising modulation technique for high-speed serial interfaces, offering better trade-offs between the bandwidth, power consumption, and the signal quality, while challenges remaining optimizing advancements in the FPGA technology and digital signal processing are expected to further enhance the feasibility of op-amp based systems. In conclusion, this project provides a significant step towards the development of efficient scalability and the high performance SerDes solutions, contributing to the evolution of 100 GBs and the beyond Ethernet communication standards. Thank you.